It's 9:10 in the morning. Well, at least that's nice, because finally I got some rest. So chapter 6, it's space. So, what is space? The ultimate aim of physics is to produce basically very general theories about the entire universe that can be applied to everything. And the ultimate test of that theory is if it can explain the whole universe as one. And by that, it means like anything from this, the pencil point, the atom in one of this pencil point. Please focus on the pencil point. Please focus on the pencil point. Pencil point. There we go. To the great depths of that building, and all the way to our sun, and to even black holes. Now, astonishingly, physicists have been actually able to learn loads of things just by staying on this flat Earth. About what stars are made of, that's why we're made of stardust, people, and the origin of the universe, and many, many other things. Also, the Big Bang is probably just a very, very terrible name for it, too. And so let's get to start with. So how the universe began. Lots of people thought it was always here. And that there was nothing that you could do about it. There was no beginning and there will be no end. Ha ha, we are the best. We will survive forever. You know, that was just kind of wrong. Turns out, lots of people nowadays believe in a more beginning way, unless you're religious. They call it this, the Big Bang. Now, the Big Bang isn't pretty much anything worth calling the Big Bang, because instead of an explosion, because there was no air in space yet, you could probably just call it the Big Inflate, as instead of a bang, it just inflated pretty fast. Electrons and quarks were made, then like several hundred thousands of years later, quarks were made so that they could create protons and neutrons. Then another several hundred thousand years later, the first atoms come into being, and then stars, and eventually our own galaxy seems to start to form. Now, how do we know about the Big Bang? There's just something called the cosmic microwave background, because if you remember from a previous episode, like if you look up at the moon, you're just seeing what happened to the moon 1.3 seconds ago, because it took 1.3 seconds for the light from the moon to reach us. That's the same thing for everything else. If it's like, let's say there's a star 5 billion light years away, that'll take 5 billion years to get here, because, well, we're seeing what happened to that star 5 billion years ago. We're looking into the past whenever we look up at the sky. And if we go far enough, and apparently we can go back to the beginnings of the universe, which is billions of years ago. Now, people always wanted to make sense of the sky. They tried to model the solar system themselves, and they're like, oh wait, if we can model the solar system, let's just go ahead and make some models. And they literally call these things armillary spheres. And they had to keep updating them because scientists kept finding new things too. Now, then this Copernicus guy came in and he said, this makes sense, doesn't it? The sun doesn't orbit around the Earth. The Earth orbits around the sun. And everyone, and then almost everyone thought it was rubbish. You could said, rubbish! I can literally see that the sun is going around the Earth. And it's like, if the Earth is going around the sun, then why don't I feel the wind? Why don't I feel the wind of me moving? And then eventually later we found some answers. Like, but if you're on the Earth, the sun would seem to be moving because it's of perspective and relativity. And then also you don't feel the wind because the place where wind exists is our atmosphere, and it's moving at the same time as our Earth, which means it's not making wind. However, yeah, sure, even though this was accepted, there are some problems to be demonstrated with it. For example, Mars. Mars was it was a very, very backwards planet. Sometimes it sped up in its orbit, sometimes it slowed down, and sometimes it just went backwards. And so the up-to-date armillary spheres had a hard time actually predicting of what was happening there, until this guy named Kepler was all like, hey, it goes in a sphere. Oval or ellipse as it's called. So it's going like that. And then we found out about the solar system. Now it goes like Mercury, Venus, Earth, Mars, Jupiter, Saturn, Jupiter, Saturn, Uranus, Neptune, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Yeah, I don't remember the song that well. And from there on, lots of things seem to start happening. And then we found out about Pluto, and then we found out that it was a dwarf planet. Dwarf planets! Google up white dwarf planets or dwarf planets yourself. And how can you tell how hot our sun is? And how can you tell how hot another star is? Well, like this. This is a starlight's signature, and we basically just send in starlight of a specific star into this little absorption thingy, and then it goes into spectrometer, and that gives us this sort of electromagnetic spectrum of visible light. But there are dark lines there, and wherever those dark lines are unique for every star, unless they're like exactly the same properties, which is rare. And I'm not even going to talk about black holes because that would make this video long. But now I'm going to talk about the end of the universe. Now, well, let's just talk about black holes. Black holes are basically what you think it is, and we have no idea if it exists, right? No. Well, it bends the light around it. It's like a sucking thing that not even light can escape it, which is why it's black. And the things around it seems twisted because we know it exists because it bends the light around it, and also whatever, and we've seen things getting sucked into it. But theoretically, if you try to get into a black hole, you will not survive. You undergo spaghettification, and if you survive it, then you probably go into also one of the most plausible theories is that you get into another universe. So this is a pretty cool thing. And now our final topic: the end of the universe. Dun dun dun! Now lots of people have zero idea of what's happening, but there are 4 possibilities that can happen. Firstly, heat death. Now this isn't how the universe will die. I mean, I actually expected a gigantic fiery inferno. It's not death by heat. It's the death of heat. So this is how it works out. So basically, the suns die out and nothing works again, and then everything will go away, and matter energy will be particles will eventually decay, and in the end, all matter energy will be evenly distributed. So nothing can change and nothing can interact. So everything is blank forever and ever and ever. The next thing is the Big Rip. The Big Rip is basically where literally everything made of matter rips apart. Even atoms, quarks, electrons, muons, all those kinds of things. And eventually the black holes will die too. Yikes. Now this is where dark energy seems to win against matter, because that's basically what makes this universe livable, by the cosmic tensions between dark matter and energy and matter. However, if matter wins, then it'll be the big crunch that will happen. It's basically where at some point everything will go into reverse, where everything goes into one little singularity. Sounds familiar? Because that's what powers black holes. And it's like everything moves together, they crunch together and smashes together like fusion energy, but instead it just goes into one little singularity. And the next one is personally my favorite because it means the universe can last infinitely and infinitely and infinitely. This one is called the Big Bounce. Now, it's where everything comes together into the singularity and then it explodes back into another Big Bang. Now, most scientists actually think that the Big Rip or the heat death are more likely. But the heat death is more likely too. But that means the universe will be gone. Well, one benefit about this is that it's the only way we can have our universe as the longest. Also, personally, I don't like the Big Bounce because I would like the universe to not die and to keep living on forever. But because if we can reincarnate, then I hope that my days in death will not be over. And so that's pretty much it. So I really hope you guys enjoyed this episode of Hunter and Sean. See you guys soon. Until next episode of Hunter and Sean. See you guys soon. Now, peace.